I want to tell you the story of the biggest gold find ever made in the USA. It's a discovery that turned Nevada from a state full of ghost towns into the biggest gold producer by far. And it wasn't a discovery made way back in the 1800s. It was a discovery made during my lifetime. Don't believe me? Well, okay, let me show you a graph to prove it.
So take a look at this chart. This shows the gold production of the United States since about 1840. And you can see in the early years before the California gold rush, we had some production from the East Coast, but the first real big rush was the California gold rush. And then we had other rushes after that in the later part of the 1800s. And then around the turn of the century, when cyanide was developed, there was also a number of big finds made in that time frame, including Cripple Creek in Colorado, Goldfield and Tonopah in Nevada, and others. And so there was a big increase then. It petered off, and then the Great Depression, people went to mining gold, and the president raised the price of gold from $20 to $35, and that stimulated a lot of mining. But after World War II came along and there was an order to close gold mines, the production dropped way down. And even after the war, it didn't come back up to what it had been. And it continued to drop as inflation eroded away what $35 could buy. And so eventually, there was in the 1960s, the late 1960s, these discoveries of Carlin, and then the increasing price led and better understanding of the Carlin deposits led to an increase. And you can see the increase that began around 1980 just rockets up and is far higher than the California gold rush, the turn of the century, or even the Great Depression. It's much, much higher production. And while there are some other mines in other states, California, a few, Colorado, Alaska, I think there's a couple others, 80% at least of that big spike up beginning in 1980 is coming from Nevada sediment-hosted, mostly sediment-hosted gold mines, the Carlin Type deposits.
Hey, I'm Chris Ralph, the professional prospector, and today we're looking into the story that will help you understand some things of the greatest gold find ever made in the USA. You see, a century ago, before this find was made, Nevada was kind of on its last legs. You know, Nevada had always been a mining state, and it had always depended on one discovery after another. You know, when one boom was dying out, well, there was another boom happening. But in the early 1920s, 100 years ago, they were not doing so great. You know, there weren't new discoveries being made of any significance, and the old discoveries were past their prime, and production was petering out, and mines were closing, and miners were getting laid off, and the old boom towns were turning into ghost towns. The once rich state was shrinking. When the Depression hit around 1930, the state was in really dire straits. The state legislature enacted some kind of crazy measures to try and help bring people to Nevada, to bring business to Nevada and help Nevada. And this included legalizing gambling, which we know Nevada for today, but it also included legalized prostitution and quickie, easy divorce. But things in the mining industry were about to start to make a little bit of a change for the positive. You see, in the mid-1930s, a few mining companies, not a lot of them, but a few, started to make some interesting new discoveries that were kind of different. And these unusual discoveries were made in sedimentary rocks, which is a kind of rock that doesn't normally have a lot of gold in it. Indeed, these deposits were different than any other deposit that had been found on Earth up to that time. It wasn't enough to really fully turn the tide of Nevada mining, but it was a start. And some geologists that were looking into this realized that these deposits were really weird and that they were like nothing that had ever been discovered on Earth up to that time. A geologist from the U.S. government went to one of these sites that was appropriately named Gold Acres, and he visited the mine that was going on there in the 1930s, and he saw something that was just really different. He noted that it was totally impossible to distinguish between what kind of sedimentary rock was ore and what kind of sedimentary rock was waste, except by doing an assay. And he also said that it was also impossible to obtain even one tiny color, by panning the ore. You'd have an ore that gave a decent assay, you'd crush it all up, pan it out, and you'd get nothing, not even a speck of gold. And yet the assay told you there was gold in that rock. And the reason you couldn't pan anything out was because the gold was truly microscopic in size. It was really small. Now, you could see it if you had a good, powerful microscope, but the gold just wouldn't, go through panning and come out in the heavies at the end of a panning session. In the final paragraph of his 1939 report that he made about his visit to Gold Acres and some of the other mines in the area, he noted that these sedimentary gold deposits didn't possess the kind of indications that the old-time miners would have looked for in the 1800s. That's why these gold deposits existed in Nevada, but in the 1800s nobody found them. That's why, because the indicators didn't really show anything. And he also speculated, which is true, that because the old timers worked a lot by panning, if they saw something that they thought might be ore, they'd crush it up and pan it. Well, because this didn't do anything when you panned it, it's stuff that the old time miners would have overlooked. He cited several other deposits in addition to Gold Acres that had been found about the same time, including the Getchell mine up in Humboldt County and the Standard mine over in Pershing County. And he noted that these were similar deposits in sedimentary rocks. He said that he expected that there were a lot more of these deposits maybe out there that had been overlooked in the 1800s, and that people needed to start looking for them because the future of Nevada mining kind of depended on making a lot more of these kinds of discoveries. He figured that they'd be found in areas where you had sedimentary rocks fairly near to acidic intrusive rocks, and he thought that there would be some of these because that kind of combination where the two rocks are close together is a pretty common situation in Nevada. Now, a guy named John Livermore, who was a geologist who was interested in gold, first read Vandenberg's report from the 1930s. He read it about 10 years later in the late 1940s. And he thought about what Vandenberg said and kind of agreed on it and thought, boy, this guy has, pointed out something that's an excellent possibility for gold finds to be made in Nevada. By 1961, Mr. Livermore was working for Newmont Mining, and he was at that time doing a copper exploration program in Nevada. And while he was there, he took the time to visit that Gold Acres mine that Vandenberg had gone to. And he talked to the manager there and discussed the whole idea of these unusual sedimentary hosted gold deposits. And the guy who was the mine manager had also been interested, obviously, in the same topic. And he told Mr. Livermore that he thought the best place that you might look for these kinds of deposits was not near Gold Acres mine, but in another part of Nevada, up in northern Eureka County and parts of Elko County that adjoined to that part of Eureka County. Livermore thought about what he said and was able to convince the management at Newmont Mining that they ought to engage and take some time to look for gold deposits in that part of Eureka and Elko counties because they agreed with him that there was some real good potential there. When they began the program, Mr. Livermore was joined by a guy named Alan Coop, and together they went out to that part of Nevada to go explore and see if they couldn't find some of these sedimentary hosted gold deposits. The first thing they did was they went to some of the existing mines in the area and studied the rocks and studied the faults and the different exposures of rock in the area. And with their newfound knowledge, they actually went out and started looking for deposits like that for themselves. And actually within a couple weeks, they started finding some really low grade deposits. They sampled what's called jasperoid, which is a heavily silicified rock. It's basically the sedimentary rock, but by hydrothermal solutions, hot solutions coming up, it's deposited silica, quartz into these materials. And so you get a body that kind of looks like crummy grade of jasper, but it's basically silicified rock. And they were getting values around, about 1 gram per ton, which today is really not that terrible, but way back then, that wasn't mineable rock. That was low-grade indicator, but nothing that they could call a mine. Because they were getting some of these, microscopic gold deposits, even though they were really low grade, and this was something that, like Mr. Livermore had seen, was easily overlooked, they decided to go ahead and stake some claims. If they were going to put more time into an area, they wanted to have a claim on it, which is good advice for anybody who's out seriously exploring. Before you put any significant time and effort and money into exploring an area, you want to make sure that you have a claim on it, you've got it in your hand, and your claim is valid, and you're good to go, so you don't explore around, find something, and have somebody take it away from you. They went and staked 17 20-acre claims, which really 17 claims for these big mining companies is really not much. It's just a little bit. But it just so happened that the area that they decided to explore, based on what they were finding in these jasperoid bodies, turned out to be just the right place, and was over what was to become the future Carlin mine. In early 1962, they brought in a bulldozer to make some trenches, cut some trenches to better expose the rock that was there, and to also make pads for drill sites. So drilling equipment could come in and drill holes and test the area down below to see what there was in it as far as gold. And they used the previous geological work that they'd done at the end of 1961 to guide them through doing this. They took samples at various places on their 17 20-acre claims, and they got some decent numbers. They actually had some surface samples that they took that were as high as 3/4 of an ounce of gold, which was, hey, even back in the early 60s with gold at $35 an ounce, that kind of rock was good mineable ore. But they brought the bulldozer in and had it cut a trench across an area where there was a porphyritic dike, because they thought that the porphyritic dike, the intrusive rock that was some part of the development of the deposits in this area. And so they cut this big trench across this dike and sampled the dike, and guess what? The dike itself was really low in value for gold. But adjoining to the dike, next to it, the sedimentary rock had an 80-foot width of 2/10 of an ounce of gold. And even back in those days, on the surface, 2/10 of an ounce of gold, that was mineable ore. So they were very excited to make this discovery. It was the first discovery of an actual area that was to become part of the Carlin mine. In another area, Mr. Coop took some samples off the surface. He found a couple pieces of float of rock that just really didn't look mineralized. It didn't look anything special, but he took samples of it because it had clearly been leached by different hydrothermal fluids, and it had kind of taken out a lot of the calcium carbonate, the lime in it, and made the rock kind of porous looking. And so just out of curiosity, he sampled some of these porous looking rocks, and they came back at 0.22 ounces per ton. Again, a little bit better than 1/5 of an ounce. And again, on the surface, that's mineable ore. So they quickly decided to set up a drilling program for that area. And it turns out on the third hole, they would do them in sequence, testing that area where he found that interesting float on the surface. The third hole, taken from right near the area where he picked that surface float up, turned out to have 100 feet of altered carbonate rocks that averaged over 1 ounce per ton. This was the second significant find in the Carlin mine area, what would become the Carlin mine area, and of course by far the most spectacular at over an ounce per ton. But that high gold value was obtained from what seemed to be unmineralized and unexciting, boring looking rocks. It really looked nothing like any type of ore that Mr. Livermore or Mr. Coop were used to seeing, because they were geologists and they'd seen a lot of different kinds of ore. It didn't look like anything. But sampling of more float and outcrops in the area yielded now values of up over 2 ounces per ton. And continued drilling over the next year or two rapidly outlined the Carlin ore body that was to be mined, and yet it consisted of these rocks that didn't look like much. Let me show you some of the ore that really looks dull and boring from these sediment-hosted deposits.
Here's an actual piece of Carlin ore from the mine itself. It contains about 3 grams per ton of gold, maybe a little more than 3.5. But it really doesn't look like anything. Even the white little veinlet on the far left side is just a little bit of remobilized calcite, very common, and it's not a quartz vein. And yet the rock itself looks like really nothing. It's just a sedimentary rock, some limestone that's been had a little bit of iron added to it, but not much. It's oxidized. It really does look like nothing to speak of. Here's a piece of Carlin type deposit ore that, again, it just looks like a piece of sedimentary rock, a limestone with a number of little lines in it. But, these layers in limestone are very common and don't mean anything. And so, but this rock is ore at the Turquoise Ridge mine, which is in Humboldt County. But yet it looks like nothing that the average geologist would ever recognize as being ore. Here's another kind of ore that's very common at many of the Carlin mines. It's called a collapse breccia. And what happens is the mineralized fluids that are a little bit acidic go through the limestone rock and dissolve out so much of the limestone rock that it creates voids. And rock eventually collapses into it, and you get this breccia, where the limestone is the gray rock in this, and then the brown clay that kind of fills in around the limestone is what filled up the void that was left from the collapse. And all of this contains values in gold. Here's a selection of ores from some of these Carlin type mines in Nevada. The picture at the upper left, marked A, you can see these sedimentary rocks, various markings on them from 2 grams to 20 grams per ton. But they all look the same. They just look like oxidized chunks of sedimentary rock. B, you see the gray material there. This is unoxidized material, but again, it just looks like a gray limestone. There's really nothing special to look at. In C, with the lower left, you see on the right-hand side of the pit the more brown-colored materials. That's the oxidation area. And then the gray on the left-hand side is more the area that has not yet been oxidized. It's rock more like what's shown in the B square above. And also in the D square, you see the same guy looking at rock. And again, it just looks like your standard sedimentary rock, and yet it has 4 grams per ton of gold in it. Here's a small pit dug in Carlin type ore. You can see more on the left is the more oxidized material, and then the gray on the right, the more unoxidized, although on the far right there's another area of red and brown that's been oxidized. But still, this just really looks like standard sedimentary rock. Now, these kinds of rocks are super, super common, and just because you found a gray piece of limestone doesn't mean that it's going to be gold ore. In fact, there's a 99.999% chance that it's not going to be gold ore. These are unusual deposits and found in a few places in the world, Nevada being one of them, but there's a few other places. It just is an unusual occurrence. The only way to know is to have it assayed, so if you're convinced you need to know, be sure and get that rock assayed and find out for sure if it has any gold in it.
They continued to drill, like I say, and they continued to strike more and more really good surface mineable ore that could be mined with an open pit. And when the Carlin mine finally began production in April of 1965, Newmont had analyzed the ore body and came up with the numbers that there were 11 million tons of ore, and that the 11 million tons, averaged almost a third of an ounce of gold per ton. And of course, this was a time when gold was still officially pegged by the government at $35 an ounce. And that greatly limited what Newmont could mine as ore. They couldn't mine lower grade materials and make any profit at it because of the low price, the $35 an ounce price of gold. The discovery of the Carlin deposit, which is really the greatest gold find ever made in the U.S., was closely followed by a number of other deposits in that same area. And the Carlin Trend Belt, meaning the whole region associated with those rocks that turned out to be rich and gold bearing, it turns out that they were able to eventually identify that this belt the gold bearing belt was 5 miles wide and 50 miles long. Now, not every area in that 5 by 50 miles is a rich gold mine, but there's a number of different deposits, some of them extremely rich, that are located along that 5 by 50 mile trend. In fact, there are more than 20 major deposits within that, and a number of smaller ones, and even the smaller ones are still pretty good sized. When the government finally in the early 70s lifted the restriction on gold and the price was allowed to match what the market price was for gold, the price of gold, I remember, because I was alive then, rose up to over $300 an ounce at one point. And that created a whole lot of excitement, and a lot of lower grade material that was found with these Carlin deposits became interesting ore that could be mined and worked at a profit. And it stimulated all sorts of exploration and a lot of positive discoveries all across Nevada. It turns out that Vandenberg, the government geologist who predicted that these things were going to be something significant and there probably would be a lot of them found in the future, turns out he was right. And that many of these deposits were actually in areas that were not far from where miners worked in the past, and certainly would have been looked at by the early day miners, but they didn't see them because the gold is microscopic, they couldn't pan it out, and the rock just looks like nothing. It doesn't look like a quartz vein, it doesn't look like anything exciting, it just looks dull and boring. And because it looked like nothing, they probably didn't sample it much, and because they didn't sample, even if they did sample it, they would pan it and not get anything, and so they'd be convinced it was nothing. And it turns out that a lot of these deposits were along certain trends and lines that you could kind of draw a line, even though it might be 5 miles wide, and there would be a series of these deposits along that line. It just happened to do with how the crust was moving, the Earth's crust was moving in Nevada in the early days when these deposits were formed. And like I say, they were found in a number of different areas. Some of them were in the trends, some of them weren't. Some of them were near known mines, like one of the biggest ones was actually found near that Gold Acres that was visited by Mr. Vandenberg and visited by Mr. Livermore when he was just starting to think about these things. It was this continual discovery of more and more and more and more deposits that basically changed the trajectory of Nevada. And Nevada went from a small to medium-sized producer to a gigantic producer. Literally, the United States is like the 4th largest gold producer in the world, and like 90+% of the gold that the U.S. produces comes from Nevada. Let's take a look at some Nevada mining trends map and talk about it and what it means and how it would affect you as a prospector.
So here's a map that shows the trends that contain these Carlin-style ore bodies. And it basically shows all the ore bodies that have been found in Nevada up to the time this map was made. Unfortunately, this map is a good 20 years old, and there have been quite a few discoveries made since the map was made. Most of the discoveries have been made inside these trends, inside the 5 red boxes that I've drawn, but there's been some of them outside. As you can see by looking at the map, there's some little dots that are outside. Now, if you're looking at this on a cell phone, you might want to look at it on a larger screen because you really need to see the detail of this. But there are 5 trend zones for these Carlin deposits. The northernmost is the Independence, or sometimes called Jarrett Canyon trend. The Getchell is the one on the northwest. The Carlin trend, the main largest one, is kind of in the center, and then to the southwest is the Eureka Battle Mountain, and to the southeast the Alligator Ridge trend. But again, there are a few dots that are outside this. The dark gray marked on this map are areas most favorable for the Carlin type deposits, but the light gray is areas that are possible or permissive for Carlin type deposits, and you can see there are some outside of it. And because this map is old, there have been some finds that have been made outside the trends, though most of the finds that have been made in the last 20 plus years have been inside these trends. But this gives you a good idea where these deposits are located in the state of Nevada, and there's just a large number of really huge producers in all of these trends.
The Carlin type gold deposits in northern Nevada contain more than 6,000 tons of gold. They're second only to the Witwatersrand deposits of South Africa for their gold. So how can you find some of these rich gold deposits like this? How can you get involved? It's not easy. They're not quartz veins. They're not even stockworks of small quartz veins. And they just look like unmineralized sedimentary rocks. And the truth is, the vast majority of all unmineralized looking sedimentary rocks really are unmineralized and don't have any significant amount of gold in them. The best places to find them are in the Nevada trend areas that we just looked at. You can Google on for the mining trends, gold mining trends of Nevada, and get more maps and more information. But I'll tell you that these trends are so well known and so famous that most of the areas that seemingly could be prospective for a gold deposit have been claimed up by various mining companies and other individuals. Now, there have been some deposits, as we saw on that map, that are off the trends, that are out and away from, and we continue to make more discoveries of these things as time goes by. Not as many discoveries as were made in the early 80s, late 70s, early 80s, when people were really starting to look for these things big time. But we still are making new discoveries. It's hard to find these deposits, and so new discoveries still happen as people make discoveries on their properties. But like I say, almost all the known trend areas are pretty well claimed up. Let's take a further look at the geology of these deposits to better understand them, and that'll help you better understand how you could go out and find perhaps some deposits like this for yourself. The Carlin type deposits are strata-bound, a disseminated gold mineralization occupying carbonate type rocks, rocks that have significant carbon. Sometimes it's limestone, sometimes it's slate or shale that have some limestone in them. And they've been altered by heat and pressure to varying degrees. Their location is usually controlled by steep and very deep faults, but can be also controlled by favorable strata in the column of sedimentary rock. So if you get a carbonate layer that's got the right kind of consistency, the fluids will go out into that. Whereas if you have other material that isn't as porous, you won't get as much fluid in them, and you'll get little or no mineralization. With these carbonate type rocks, acidic mineralizing fluids come up the deep faults and get into these carbonate rocks and literally dissolve away the lime, the calcium carbonate, leaving behind dolomite, silicified rock, breccias. Sometimes they eat out so much of a void that there's a collapse. And so you have a breccia formed of the pieces of rock that collapse downward. These are called collapse breccias. And then also the mineralization can be found in these jasperoid bodies. Early on, when people were searching for Carlin deposits, they over-focused on the jasperoid to the extent that they kind of ignored other stuff. And so not all these deposits have much in the way of jasperoid, but some of them do, and some of them the jasperoid is mineralized and some of it isn't. So the jasperoid is not something to just focus on exclusively. It's more the right kind of rocks, but the jasperoid is commonly in there. And there are even a little bit, usually mixed in with the sedimentary rocks, of various intrusive dikes. And sometimes these are mineralized. The typical mineralogy of these kinds of deposits include both gold, of course, that's what we've been talking about, and it's always very fine grained, but there's also fine grained pyrite, arsenopyrite, realgar, which is an arsenic mineral, orpiment, another arsenic mineral, arsenopyrite, cinnabar, a mercury mineral, fluorite, barite, stibnite, and of course, quartz. Sometimes there's carbonaceous organic material. Literally these hot fluids going through sedimentary rocks. The sedimentary rocks may have small amounts of organic material, and so they may kind of pull up and concentrate the organic, which is basically like a tar or a thick oil kind of thing, may concentrate this in certain parts of the rocks. The deposits contain generally less than 1% of very fine-grained sulfides. And often the replacement or leaching or dissolving of the carbonate rocks, of course, is most intense near to the fault zone that provides the mineralization that comes up from below. And like I say, these fault zones provide an important source of high grade or of mineralized fluids that bring up the gold and other minerals up to the layers of sedimentary rock that receive the mineralization. And they actually have found below some of these types of deposits along the fault, they've actually found some quartz vein type of enriched deposits that are down below there. Now, some of these things are predominantly sulfides, and some of the Carlin deposits are oxide based. It happens to be that the sulfides in the primary original rock that was formed, once they're near the surface, they're subject to weathering and air, oxygen from the air, and so the material gets converted from things like fine-grained pyrite to iron oxides, and then at least you can see the iron oxides a little bit. But it comes in both types. One is easier for the miners to treat than the other. The oxide is much easier to treat, but there are techniques for processing the sulfide ores as well. Let's take a look at some diagrams to better understand these deposits and how they form.
Here's a conceptual design of how the Carlin deposits form. And in this particular diagram, the light blue is silty limestone and the dark blue is limey siltstone. And so, either way, there's significant lime in the rock. And then above it, it says siltstone, which is something that will not change much by the effect of the fluids that are coming up the fault zone. So you've got this fault zone from down below, it comes up, and it hits the areas where it can attack the rock because it's acidic. It dissolves the rock, and that's marked as decalcification. That's the yellow. So it spreads out into the rock zone, and then close to the fault, you get the actual ore. You also get, along the fault, a breccia. Some of this is what we call void breccia or cavity breccia, where you open up something and then you get slipped down as rocks fall. And then the dark gray there is jasperoid. So there's also silica coming up the fault, and it deposits silica, and so you get this jasperoidal rock, or basically where the rock is converted to a really low-grade jasper. But this gives the idea for you of what these things, if you were to take a slice through them, how they look and how they form. And I've kind of outlined where the ore is with red. It's been about 40 years that geologists have been really searching hard for these deposits in Nevada. And so the ones that are real obvious on the surface, yeah, those pretty much have all been found. But ones that are hidden or covered over with something, some other rock, or even covered over with just sand and gravel, those things are still waiting to be found. And this is a graph of hidden type Carlin deposits. And so we'll just go through these. I've numbered them. So number 1 on the left is where the minerals came up the deep fault and then hit a thrust fault, which is a flat fault. And basically the fault zone acted as a cap to hold in the fluids. And so the fluids came up the fault and then spread out along the fault going up, and you get a deposit there. Now, here in this graph, the guy who originally did it noted toxics, and what he means by toxics is deposits of arsenic, antimony, and mercury, all of which are pretty nasty toxic elements. So that's what they mean there. So you do get a zone of these toxics or other elements, indicator elements, out around because it spreads out farther than the gold. Okay, so that's number 1. Number 2, you've got fluids coming up, and basically it hits the zone of the limestone and stops. And number 3, there's probably some fracture as you've got a bend like that. So where you have a bend, you often have a fracture zone, and the fluids would come up and deposit in that fracture zone because it was opened up, and therefore the fluids to come in and react. But it shows on the surface that you might get a zone of these toxic elements plus bleaching and other signs of calcium minerals like lime being dissolved away. Okay, so that's 2 and 3. And then 4 and 5, the 5 you have just a tiny exposure on the surface near the fault, but then, which wouldn't be a very significant deposit, but then down deep you have a much larger deposit, and that's where on the surface you got a little bit, but down deep it's reacted in that rock, and so you have a significant deposit even though there's not much showing on the surface. And then number 6 and 7, again, you've got a much deeper deposit with not much exposed on the surface for number 6. And 7, it's on the other side of the fault, but there's basically a favorable bed that the material was able to eat into. And then they're noting that above that favorable bed, you might get strong calcite veining, which is a remobilized calcite where you have the limestone and it's been partly dissolved, but then when it gets further away from the source, then you get these little veinlets of calcite that indicate the mineralization. So that's a kind of a summary of what they mostly are looking for now, which was the hidden type Carlin deposits.
The Carlin type deposits are some of the largest hydrothermal based deposits in the world. And the nature of the gold being so small that it's microscopic, sometimes people call it invisible. It's not invisible, it's just microscopic. It's invisible to your unaided eye. You can't see it without a microscope. But the really small size of the gold makes it very difficult to find these deposits. And even though we're still finding them occasionally, they're way less than obvious. That's the whole point about them. It normally takes a whole lot of testing and assays, and literally you can be, taking dozens and hundreds of assays to find the spot where these rocks are, and the assays are not cheap, and this puts the small prospector at a distinct disadvantage to the big mining companies who have geologists that go out and they have a budget of thousands of dollars and no problem take 1,000 samples. If that's what you need to do, they can do that. Whereas 1,000 samples would probably be something on the order of $30,000. So the small miner is at a definite disadvantage when it comes to doing a lot of assays. One of the most important things, though, is understanding the favorable rocks, because in each of these trends, in different areas in Nevada, the favorable host rocks vary somewhat. They are of a similar nature, being, like I say, limestones or siltstones and with some lime in them, and shales with some lime, being rocks like that. So there's certain formations that are most favorable to having these deposits in them. And knowing what those formations are in your area and being able to recognize them will definitely give you an advantage. And still, like I say, they're difficult to find even for the most experienced and knowledgeable geologists. The Carlin ore bodies are very large and contain both low-grade ore and high-grade ore. And they're mined both by surface open pit type mines and underground. But both the open pit and the underground mines, the workings can be huge in size because they involve vast amounts of rock. The higher grade ores are processed, whether they come from an open pit or underground. The higher grade ores are processed by a conventional vat leaching process. If it's oxidized rock, if it's sulfides, they have what they call an autoclave process, where they heat and oxidize the sulfides in a compression chamber, where they can elevate the temperature and the pressure and add oxygen in there, and that accelerates the oxidation of the pyrite. But once it's oxidized, it's the same as stuff that's been oxidized on the surface. They crush it very fine, they put it in a vat, they stir it up with cyanide, cyanide dissolves the gold, the solution containing the gold is processed, and the washed, cleaned, crushed rock is then something that becomes waste. But because these kinds of deposits produce a whole lot of low-grade rock, there was a problem in the early days because there just wasn't methods to treat that kind of lower grade rock economically. And so not long after they discovered these deposits, the Bureau of Mines developed a couple of techniques that allowed miners to treat these rocks very inexpensively. And the two different things that they developed, one is called heap leaching technique, and the other is recovery with activated carbon. So they were able to take this rock, maybe do some minimal crushing, or sometimes they don't even crush the rock at all. Just whatever breakage occurs in blasting the rock is what they get. And they take it and pile it on a heap. And usually the heap has underneath it a very thick layer. I actually did one of these projects. I was the engineer, and we had a sheet of plastic that was 1/8 of an inch thick, 1/8 of an inch thick. And it was on a prepared surface, so the surface didn't have rocks to poke holes and break the sheet of plastic. But we laid down this very heavy sheet of plastic, and we put some material on the surface of it, and then piled up the ore that we wanted to treat. Now, we did crush ours some, and so it was crushed to, I think, about -1/2 inch. And then we put it on there, and then we sprinkle cyanide. This is the process. It was developed originally by the Bureau of Mines in the 1960s. Like I say, not long after the Carlin discovery, they developed a technique to treat the low-grade ores. And then we piled this stuff up, and then you have various ways of sprinkling on the cyanide solution, which is pretty dilute. It takes a fair amount of it. It's not real high concentration. It's low dilute concentration cyanide, and it's sometimes put on with just drip irrigation, sometimes various types of sprinklers and that sort of thing. And as the liquid cyanide goes through the heap and percolates down, it actually dissolves the gold as it's going through this pile, through the heap. And then at the bottom, like I say, we laid this heavy layer of plastic, and that's always set on some sort of grade, so that when the stuff percolates down, it hits the sheet, it goes down along the sheet, and then goes into a collection pond where it's collected. And now the solution has gold, and if the deposit has silver, it'll have silver in it too. So then you have this liquid that has the gold and any silver in it, if there's some silver in the rock. You take that, and the technique that was developed by the Bureau of Mines is that you can pump it through cylinders of small bits of activated charcoal, and a lot of times they use coconut shell as a byproduct. Apparently it makes really good activated carbon. They fill cylinders with it, and then they pump the solution through these cylinders, and the carbon of the activated carbon absorbs the gold out of solution, and then it goes into another barren pond after the gold and silver has been stripped out of it, and then any additional cyanide or lime that's necessary to bring the solution up to strength is added, and then it's pumped back on to the heap again and allowed to percolate through. And so it's a continuous process. You add water to make up for any evaporation, and you add cyanide and lime to get the pH and the cyanide concentration that you want, and it's just an ongoing circular process. Now you end up with the carbon that has gold and silver loaded onto it, and then there's a process of stripping that off and recovering the metallic gold, and then it usually is recovered as a powder. We had ours when I was doing it. It was a kind of a dark gray powder because it had some diatomaceous earth in it. That's what it would have been, more black, but with the diatomaceous earth it was more gray. And we would melt that down and pour a bar of impure gold and silver, and then we would send that off to a refiner and we would get paid for it. And the process of doing this heap leaching, it's very inexpensive because, like I say, either you do a preliminary light crush or you just put mine run material on the pad. You allow stuff to percolate through there, and it will get a decent percentage, depending on how well you crush it. It gets a decent percentage of the gold and silver out of the rock, and it's a very, very inexpensive process. Let's take a look at some of the mines, the Carlin Type mines, and then their processing and how that works. We can understand that a little bit better.
The important thing to note about these deposits is that they are vast and huge, and this is just one, but there are many of them, and they produce incredible tonnages of rock that has lots of gold, and that's how this becomes the greatest gold find in the U.S. And the heap leach piles that they make are also vast and huge. I mean, this one, it's hard to take a picture of it so big. I was quite a ways away to get most of it in the frame of view. It's probably close to a mile long, and at its widest, maybe a quarter of a mile wide, and is hundreds of feet deep. And so you can imagine how much huge amount of ore goes on to these heap leach piles to have their gold and silver extracted. This is just a simple diagram of the heap leach system. You have a barren cyanide solution. It's put onto the pad through some sort of sprinkler or drip irrigation, that type of thing. You have an impervious pad underneath. Like I say, for us, we used about an 1/8-inch thick sheet of plastic, and that's what a lot of people use in those designs. And as the water percolates down through, the cyanide dissolves the gold and or silver, and then the material's collected at the bottom when it goes down into what they call the pregnant cyanide solution. But you can see with the piles as huge as the ones I showed you, it can take weeks for the liquid to sink down through there, but it's a continuous process. They're constantly putting more solution on and constantly taking the completed pregnant solution off. This just shows the system. The ore column is, think of that as where the heap leach pile is. The material sprinkles down, and then it goes through carbon absorption columns and then into a container, and whatever necessary lime or cyanide to bring the solution up to full strength is added, and then it's pumped back up onto the heap leach pile again. Eventually the carbon columns get saturated. They can only absorb so much gold, and the gold is stripped off and through a process called electrowinning is converted to kind of a mud of gold, impure gold with silver, and melted down into a bar or button, which is sold to a refiner. And here's the final product, a big button of gold, some poor bars, but this is the final product, and these mines in total produce millions of ounces of gold every year, and so a whole lot of bars and buttons are produced and sold to refiners. And there's no doubt that making a find like this would certainly be something that you could make a lot of money off of.
Now, I've said in a number of my videos that everything about prospecting is a skill. Whether you're looking for unusual Carlin Type gold deposits, or you're just looking at placers, or you're looking at other hard rock quartz veins, whatever you're doing or looking at gemstones and crystals, whatever you're doing in the prospecting world, it's a skill. And the more you know, the more successful you're going to be. And that's why I wrote a book about it, because I wrote a book to transfer to you that knowledge and skill that I've gained over decades of being out in the field. And my book is called Fistful of Gold. It focuses on gold, of course. And I'm going to tell you a little bit more about my book right now.
So this is my book, Fistful of Gold. You can see it's an encyclopedia distilling down my 45 plus years of prospecting experience plus my degree into the parts that you need to know. I spent most of 10 years writing this. It was not just a simple effort that, I sat down and wrote it. You can see it's like 250,000 words. It's not something you're going to read through in a day or maybe even a week or more. But it's got a lot of information and reference material that you can come back to. You can read it once and read it again and get more out of it, because there's just that much depth of material in this. I wrote this book because I want you to have the skills to go out and find fistfuls of gold for yourself. And if you have the skills and know what you're doing and get out in the field and make a real effort, you can find significant gold. It's not easy. I'm not going to tell you that, because, gold, it wouldn't be, close to $2,000 an ounce, which is what it is right now. It wouldn't be so expensive if it was easy to find. It's not easy. You just can't walk out into an old gold field and start picking up nuggets. If the gold was easy to see and find, the old timers would have picked it up and taken it themselves. So you got to have skill. You got to know what you're doing. You got to be able to master what it takes to find gold, and you've got to have the persistence and put in the effort to find the material, to find the gold or diamonds or gemstones that you're looking for. Now, this book has geology, it has facts about gold, it has stuff about diamonds and platinum, but it's mostly about gold deposits, how gold deposits form, how placer and nuggets form, all the questions you've probably wanted to ask. The book is available on Amazon, and I'll put a link to it in the description below, but you can look up on Amazon, Fistful of Gold, and by Chris Ralph, and find this book. Now, the book, if you look on it, it has a very high rating. It has like a 4.7 or 4.8 out of 5, which is really high. I mean, it's hard to please everybody, but I'm close to a 5 out of 5, not far from it, right? So it's been out. I've sold more than 15,000 copies of this book, and I've had tremendous positive response by the people who buy it. And I think if you buy it, you'll be just as happy with it. Now, in addition to my book, I also have a website that I do, and I'll tell you a little bit more about my website and show you some images from the website right now.
Now, my website is nevadaoutbackgems.com, and I'll put a link to the prospecting page, this prospecting encyclopedia page, down in the description below, but you can find it at Nevada Outback Gems. I sell some jewelry, turquoise, other gemstones there. I don't always keep the inventory perfectly up to date, so if you're interested in anything you see, do contact me first before trying to send me money or anything, because I want you to be able to get what you order. But the website has lots of different stories, old adventures, even some stories, true stories from the old-time miners of the 1800s. So I think it's something you'll find interesting.
The other thing I want to go back to is that all my comments, I want you guys to ask questions on the comments for my videos. I answer 100% of the comments that are made on my videos. Now, sometimes if somebody just says, hey, great video, I really enjoyed it, the comment may just be, well, I'm really glad you liked it. Or, if it's a simple question. And sometimes I get people who ask me questions, oh, it would take a book to answer that question. And I recommend that they just buy the book. But I answer all my questions. I try to help people as much as I can. I'm here to help you. So if you're interested in gaining the skills, if you're interested in knowing what you need to know to be successful, follow along with me. Subscribe to my channel, hit the bell so that they'll let you know when I come out with new videos, and I try to do that pretty much every Saturday morning. And you'll enjoy with me, you'll come along with me, we'll have an adventure together, and we will find some nice gold and see what it's really like getting out in the woods, or the deserts, or the mountains, wherever we land, wherever the gold is, wherever the diamonds are, wherever the platinum is. Come along, we'll have some fun. And I'll see you real soon on the next video.